In this exercise, we are given English sentences. Socrates is a man is the first sentence. All men are mortal is the second sentence. And we should use those two statements as premises from which we should prove that the third sentence implies, so it's a logical consequence. The third sentence is Socrates is mortal. Of course, first we need to formalize all those statements. Therefore, we need to, first of all, introduce predicates. We definitely need to introduce a predicate for being a man. Let's introduce M of X, which means X is a man. Similarly, we should introduce another predicate, let's say T of X, for X being mortal. Also, as we can see, a dedicated man is referenced in those sentences, Socrates. So this is a guy among the other humans. Of course, he can be represented as a constant. Let's say we choose the constant S for representing Socrates. Okay, now let's formalize the first statement, the first premise, P1. Socrates is a man. Of course, this can be represented as M of S. The second premise is a universally quantified formula. We are talking about all men, or more precisely, we talk about everything in the world, which we filter to man. So for all X, if X is a man, then this man must be mortal. Yes. And finally, let's formalize the conclusion formula. Socrates is a man, mortal, so T of S. What is the main goal in this exercise? We have to prove that C is a logical consequence of P1 and P2. What does it mean? It means that if we should prove that for all interpretations, if both premises are true, then the conclusion formula must be true. We should prove this. Okay, well, this is what we are going to do. Well, let's first put a question mark here, because this is what we have to prove. And let's start with the first premise, since it is a must that this premise, M of S, must be 1. So what does it imply? We continue with the second premise here. So if this second premise is true, and it must be true, then what does it mean? It means that for all X, the scope of the quantifier Mx implies Tx must be true. If this implication holds for any value for X, then it must hold also for the constant S. Long story short, M of S implies T of S must be true. And since we know that M of S is true, then this must imply that T of S must be true. There is no other choice. And if you look closely, well, this is exactly what we had to prove. We had to prove that if both premises are true, then every time in all interpretations, the conclusion formula T of S must be true. So this is what we just proved here.